Step 3, solve for x. A, x plus 4 less than 10. We have now brought in the modulus less than. So a combination of modulus functions and inequalities works this way. So you take -10 take away the modulus and bound it in that way. So you introduce another inequality to the left, but this time around the x plus 4 becomes bigger than the negative number, but it's still less than 10. So once you move one step, it now becomes a question of example 1. For yesterday, where you take 4 this side, you take 4 the other side. So now it has become -10 minus 4 is less than x, which is less than 10 minus 4. And that is -14 less than x less than 6. That's all.
Sir, I've got a question. Is it okay at first if I can just work it out where it's x plus 4 less than 10, you work it that just like that. Then at first where there's x plus 4, if I introduce a negative, meaning an x will have a negative, then even a 4 will have a negative, then I cross it to the right. Is it okay if I can go in those lines?
So you say, since I know that I have x plus 4 and negative x plus 4, keep this thing less than 10, so that the first one, it is less than 10, and the second one, it is less than 10, divide by negative, divide by negative, you get x plus 4 greater than -10, x greater than -14, so that -14 is less than x, which is less than 6. This guy, same as that.
So it's okay even to go in those lines?
Yes, for now they're not confused on how you define and divide by the negative.
Thank you.
So I'm kindly asking if you can repeat the explanation on this example.
Okay. So when you're dealing with a modulus, and there's one inequality, and the modulus will always come with one inequality. Your next step will be to introduce another inequality so that you get rid of the modulus. So if you follow this way, since we only have less than here, 10, we'll now introduce the other one so that we form 2 of them. But for the other one, there will be negative. This same number will be negative form on the left, less than the thing inside the modulus. Now without the modulus, less than 10. Then you take 4 this side, take 4 the other side, so that you have -14 less than x less than 6. Another way is you define the modulus, they will be redefining it, and keep the less than as it is, but this time around you're having 2 equations. The first equation, less than 10, you can solve it, it will give you less than 6. The second equation, less than 10, when you deal with the negative, it will change the inequality from less to greater, and then solve for x, you get x greater than -14. You can put this as one interval Since x is less than 6, but x is bigger than -14, then you can say x lies between -14 and 6. This is what we have here.
Thank you, sir.
Okay.
Sir,
Oh,
how are you?
fine. How are you?
Fine, sir. No, that's when we were like allowed to come in. We are trying to come in, but we're not like we haven't followed just from the start.
So you haven't missed anything, my dear.
It's the end of the world. Njoka zikugwa munga ni mvula. Ona David.
So what we are having here is the first example on the modulus combination of inequalities. So because of those who have just joined, we have 2x plus 1 greater, before I change the type, for those who have just joined, less or equal to 20. We are saying we have two options to make. Option 1, that is, if you want, you can solve it using option 1, where you get a -20 to be less or equal to 2x plus 1, which will also be less or equal to +20. Then take this number the other side, take this one the other side. So now we have -20 minus 1 is less or equal to 2x, less or equal to 20 minus 1. That is -21 less or equal to 2x, less or equal to 19. Divide by 2, divide by 2, divide by 2. So what we have now is -21 over 2 less or equal to x, less or equal to 19 over 2. Like that.
So, sir, if 20 was a negative at the right-hand side, then meaning to the left side, it's going to be a positive.
It will be different. Option 2, you keep 2x plus 1 less or equal to 20, or -2x plus 1 less or equal to 20. The first one, take one the other side, you get 2x less or equal to 20 minus 1, which is 2x less or equal to 19. Divide by 2, divide by 2, x is less or equal to 19 over 2. Or divide the negative there, divide the negative, you get 2x plus 1 greater or equal to -20. Take one the other side, you have 2x greater or equal to -20 minus 1. That is 2x greater or equal to -21. Divide by 2, divide by 2. X is greater or equal to -21 over 2. Now, this means -21 over 2 is less or equal to x, but x is also less or equal to 19 over 2. This here is the same as what we have here. You choose which method works for you better.
Yes, sir. You can move on.
So that
question. So for this one, there's nothing like finding the critical points. That one like finding the negative and the positive. There is no.
that one only that one only works for fractions. Where does the modulus come in? It only comes in the question, and it is left just there when you start solving. So it won't follow you in the solution. Example C. The modulus.
Sir.
Hello.
Yes, explain for me that one.
Which one?
On that one, the first one there you made, how did you come up with those two equations there? It's -10 less x plus 4 great.
What we are saying is that if you have this as your question and you want to solve it, your first step is you introduce another inequality here so that you get rid of the modulus. So as you introduce another inequality, on the left of that inequality, you put a negative number. This same 10 that we have in the question, we'll have it as -10 less than the thing we have in the modulus, the thing of the modulus less than the +10. Then once we get here, it now becomes a normal question like those we are solving yesterday. So you start solving, you take for the other side and also the other side until you get to this solution. That is.
Sir, is it the same as you separate them? Like I solve x plus 4 less than 10, and then again I solve x plus 4 less than -10. That's what you mean? Okay.
No. You don't pick only positive. The modulus is just telling us that introduce another inequality and deal with two inequalities. In other words, you split from the modulus, you split to two equations. The same way we define, remember how we define a modulus. We say this is x plus 1. So we're using the same notion. Once we define, we forget about the modulus. And the same thing happens here in inequalities. Okay. C. 3x minus 7 less or equal to -20. The solution set is empty. D.
So, sir.
Sir, why an empty set?
Empty foot. How?
Sir, how an empty set? Explain.
Because the modulus can never be a negative number.
The modulus always gives us positive numbers. So how
Oh,
does it
because of
become
the-
less than a negative number?
Okay, because 20.
Sir, can you please explain
On which one?
how I'm behind? Can you explain on C? Why is it an empty the solution set.
Look, any modulus, if I give you a modulus of -2, the answer will be +2. So there's no positive number which can be less than a negative number.
No. What if it was greater or equal to -20? You would have found the solution set, huh?
It will be different.
Huh?
It will be different.
To be different, yes. Huh? Okay.
So once I have the modulus less than a negative number, there's nothing to solve there. It's direct, the solution set is empty. There's no number that goes in the modulus and comes out negative. No.
Eh? Oh, again.
Sir, I have a question.
Yes.
Here where you are solving when you have a modulus, like where we had 2x plus 1. Yes. So like I remember when we were we are defining these same functions, we would say one would be 2x plus 1. It will be greater or equal to, okay, yeah, it will be like that. Then the other one, like if it's negative, yes, like that. The sign won't have like a equal sign. It won't have like a equal part. Like last time when
that was it. So when we combine modulus with inequality, we work under the guidance of inequalities and not modulus.
Oh.
So the inequality which is present is respected and it holds more power than the definition of the modulus.
Okay, so those moduluses didn't have were not equated to anything.
No.
They were just being defined as they were.
They were just functions, yes.
Okay, all right, thank you.
Again, sir, what if the same module as this one, like which is 2x plus 1, then it was if it were less than or equal to 20? We will find the solution set. The way it is, what the mid now there is less than or equal to. We would have find the solution set.
You mean greater or equal to?
It becomes less than.
Where it is here, it's less than. So if it is greater or equal to, we can still find the solution.
Okay.
Okay, so our next question.
I have a question, sorry. Okay, on C, so if that sign, if it was greater or equal to -20, you're saying that's when you would have found the solution set.
If it was
on C, if that sign was greater or equal to -20, would we have found our solution set?
That is the solution set.
Okay.
Why? Why is it only? Yes.
Because everything you put in the model gives you a positive.
Correct.
Sir.
Yes.
Why equal to, not just greater than -20? Is it when you put equal to, isn't that you are saying that the modulus should come out, when it comes out should be equal to -20 when you put a equal sign, or what does it mean there?
No, that equal to or what? It means nothing in our sense, except that we are saying for any value of x that we take there, the inequality will be satisfied. Of course, it will never be equal to, but then it will be satisfied.
Any value zafaka pa x. Okay?
Yes.
I'm not convinced. I explain better that I can understand.
The greater or equal to is telling us that look for x values that when you place there, what you get will satisfy the inequality.
Will be greater than negative 20, yeah.
So you pick any value. Suppose x is 0. You have 0 minus 7, giving us the modulus of negative 7. This is 7. For sure, 7 is greater than 20, than negative 20. So even if I have an equal to there, I'm not worried because I'm just using the part which is greater.
Sir,
Yes.
You are saying I just using the part which is great. Now why not removing the equal to?
If the equal to comes with a question, you don't do anything to it. You just leave it as it is and then get the solution set.
Okay.
When it's greater, equal to, how do we read it? We say greater or equal to. So if you don't have the equal to, then the greater will be working in all your conditions. So the or part is an option. Do you understand?
sir. Sir,
Yes.
Yes.
sir.
Hello.
I understood on the first one on C. Now on D. You are saying that all real numbers will be greater than negative 20.
All real numbers
But
taken where there is x.
taken where there's
Evaluated.
X will be greater than negative 20.
By the time they're coming out of the modulus, they'll get a negative 20.
Even like,
Give an example.
what if I say negative 2?
So we'll have 3, negative 2 minus 7. This is negative 6 minus 7, which is negative 13, which comes out the modulus as positive 13. Positive 13 is greater than negative 20. Is it true?
Okay, what if I choose negative 100?
It doesn't matter. 3 by
That will
negative
be
100 minus 7. That is negative 300 minus 7, which is negative 307, which comes out the modulus as 307.
Okay. All right. Okay, I understand. Thank you.
So,
hello.
Yeah, what if we solve it in the way we have solved the previous examples? For example, A and B. We take negative 20 to the other side. Then
So it does what?
We solve the equation like this, yeah, like the way, for example, B and example A. We solved in the same way for the example D for the real numbers. How would it come out? Huh?
There is no need of doing that.
Why?
When the solution is known, you don't need to solve. You only solve for the unknown solution.
Then how do you know that this is a known and this one is a non-solution?
Use the definition of modulus. Blessings, what's happening?
How to operate things, behave yourself. You're disturbing us.
No, there are
You
no
have blessing futa vewalemba yo.
There's blessings, moms and blessings, Chipango. So I don't know what the problem is.
Sir, it's my phone. It's freezing on its own. Easy them by.
Okay.
Let's respect each other. You don't know what we're passing through.
Okay, let's go to E. The modulus of, I put the negative, modulus of 2x plus 8 is less or equal to negative 10. Negative 10. So what will happen is, because we have this negative here, so we can divide it, divide the other side also, so that we remain with 2x plus 8 greater or equal to positive 10. And once it's positive 10, the question now changes. We can now solve this. How do we solve it? We'll have two equations, 2x plus 8 greater or equal to 10, or 2x plus 8 less or equal to negative 10. So for the first one, 2x is greater or equal to 10 minus 8, giving us 2x greater or equal to 2, divide by 2, divide by 2. So x is greater or equal to 1. Or 2x is less or equal to negative 10 minus 18. So that 2x is less or equal to negative 28. It's like I added that as I was writing. Supposed to be minus 8. Minus 8, so that we get minus 18. Divide by 2, divide by 2.
That the same one you're solving, it's not supposed to be there where it's supposed to be greater than or equal to.
It's here.
We have changed the sign, guys. Here,
yes, because of the negative.
I mean, yeah, the same one. The sign is not supposed to be less than or equal to.
It is less than or equal to.
Oh, I mean greater than or equal to, because there is you have changed it, guys, by the negative.
It's because we have two options. The first equation takes the greater or equal to. The second equation takes the opposite sign because you have introduced a negative. Option 2 is one that we are using here. Which has a negative introduced on the other equation as you fix the other equation positive. So that you get x less or equal to negative 9. Now,
so can you please go back to option 2?
are you seeing how it looks like?
Yes, I have. Thank you. I think I made a mistake somewhere.
Okay. So the meaning of option 2 is that since I know that when you say 2x plus 8 is greater or equal to 10, you know that the modulus thing is defined in two ways. You have it as a positive, you also have it as a negative. So you can choose to fix the 10. So you say 2x plus 8 is greater or equal to 10, or negative 2x plus 8 is greater or equal to 10. But for the negative one, the first thing you do is you divide the negative one, divide the negative one. So it will become 2x plus 8 less or equal to negative 10. So we have this equation to solve and also this equation to solve. Meaning we have two of them at each point because of the modulus, which is defined in two ways. Now, if you take the number and you have negative 9 here, you also have 1. The first one is telling us that x is greater or equal to 1. You start from 1 going to the right. The second one is saying x is less or equal to -9. You start from here, going this side. So our solution set will be -infinite all the way up to -9, included union, including 1 all the way up to +infinity. That's what we call the solution set for this question. So when I have greater or equal to with the modulus, I expect to get my solution as the union of two intervals. If I have less or equal to, you get one interval of this form.
Can you repeat those points again?
So now we'll put them in a general way. So we are saying, we note that 1, if you have f of x less than a, where a is greater than or equal to 0, your definition will be -a less than f of x, which is less than a. 2, if this is less than a, where a is a negative number, the solution set is going to be empty. 3, if this is greater than a, where a is less than 0, the solution set is all real. And 4, if f of x is greater than a, where a is greater than 0, then we have f of x greater than a, or f of x less than -a. So this does not change even if you have a set of, even if you say 1 f of x is less or equal to a, for a greater or equal to 0, the same setup will come, less or equal to a. For 2, if f of x is less or equal to a and a is less than 0, the solution set is still empty. 3, if f of x is greater or equal to a and a is less than 0, the solution set is all real. And 4, if f of x is greater or equal to a and a is greater or equal to 0, the solution set, your solving comes out this way, or less or equal to -a. So take note of these. They are the ones that we have used in all our examples.
So can you wait a moment? We are writing, we are copying the same questions, the same statements.
It will be cutting anytime soon. So as it cuts,
Everyone should just screenshot.
Also called epimers.
but I also send the thing. I also send you the PDF, is it? You always receive the PDF.
Yes, sir.
Okay.